In order to offer first-class vision applications to our customers, we work closely together with our certified integration partners. Our partners can integrate efficient software into machine vision systems. Our next guest speaker has been a long-year certified integration partner, Mr. Stelzel from the MSTVision. It's nice to have you here. Hello. I'm going to hand over to you. It's nice to have you here. See you later for the question round. Thank you very much. Hello, I'm going to talk about the HDevEngine today, as we have been using it in big projects and among several teams. It is a mixture of a project presentation and a little bit of training. I hope that you enjoy it. Let's see if the clicking works. Thank you very much. This is our agenda. We are a development service provider. The customer comes first, so we are going to start with presenting the project. Afterwards, we will have one slide about us, where we show how we integrate the HDevEngine. Then we will look at the development process, and there will be one slide for the summary. So let's start. Which product are we talking about? The customer allowed us to talk about its product. Everyone is talking about the bandwidth in the internet, and an older technology to have a higher bandwidth in the internet is to use glass fiber, as can be seen here. And our customer develops exactly this. It's the company Huber and Sune, more exactly the Cube Optics, and it can be seen on the left side. And this is the cross-section. This is a fiber that and black box, and it looks like this. In reality, this is the building component. And why are we talking about ultra compact? You can see the photo on the right to see a comparison of size. So this is really small. It's only 4 millimeters. And why is this so difficult? The customer has been developing this for years, has been on the market for many years, and has assembled more than 100,000 pieces accumulated, and it's manually assembled, assisted by microscopes, and also some imaging solutions. And this is made in a clean room environment, as you can imagine, and it's very precise, and the yield is very high. And it's being more and more important. There is a mass market, so the goal of the project is to have a fully automated production of more than 1 million pieces per year with high yield and high quality. What makes this so difficult? Well, the product is not that easy. When we started the project, the design was not finalized, and the process development was not finalized, and also what image processing is needed. So there are flexible fibers, there are shiny metal parts with changing texture, the parts made of glass, transparent and semi-transparent, with changing surface properties. There is adhesive with changing shape and changing properties over process time. You have contamination, like for example dust and particles. And for us image processors, the worst part is that there are moving parts. You have moving backgrounds, moving manipulators, and the customer wanted to have a flexible product that can be adapted in an easy way, because there will be a specific designs, and the image processing library is needed that meets the needs of the actual and future projects. And Huber and Sune has a great team. They have a lot of designers that design the product optically. There are process developers, and it is also possible to design e-plans, etc., and control cabinets. But the project is too big, so there was the need of help in automation and image processing. And there was a need for know-how and also for having an internal training. And this was like a casting. This is our marketing slide of MSTVision. I already mentioned it today in the interview. We are a small team and we work with Helcom. We are not the typical system integrator. We are a development service provider and we work a lot with Helcom. And there's a big bandwidth, and for many years we have also been doing vision applets, and we have been developing solutions, and we have a high score, and we were the first ones and to have VDI, and everything that has to do with R&D can be supported from the first idea at the whiteboard up to installing it. And we can really support with our know-how, and we can tell you how we will do it. And we have developed some great technologies. And this is really crazy. We have been working with freefall sorting, with cameras, and we have 1 million objects, falling objects per second per single line camera. And we can also use FPGA-based photometric serials, and that's everything for us. Let's get back to the project. We applied for this job, and also others applied for this job, and for automation, Muckenheim was selected, and for image processing, we were selected. And we were asked to train the employees. So then we started. This is a really big project that was going to be worked on for several months. So let's break down the risk a little bit. We made a transfer of manual process to semi-automated tabletop systems, and we offered this, the change from existing imaging software to Helcom. This was a student that worked on this in his bachelor thesis. New cameras with new optical illumination setups were used, and the goal was to evaluate if the selected team and tools were correct and to confirm or revise decisions. And we could see that the tools worked fine, the internal external teams worked fine, and for us as Helcom user, Huber and Suna was very impressed by the capabilities of Helcom. So the big project was approved, and the next slide shows the challenge. We can start the video. You can see that the different fibers, the glass parts, and everything is moving. You have to see that everything works, and you also have to see if there is enough adhesive there. And this was one of the easier tasks in the project, I have to say, but it shows the complexity. So as I mentioned, we have this big project, and someone has to think about the big architecture. In this case, it was Muckenheim Automation. They made an automation framework with the sequence controller, with robots and PLC, and there are many other architectures. We have heard about SIG today, about others. So the many approaches, and also we as Helcom started working on this and how this can be integrated. Now is the know-how transfer slide that I prepared for today. This is a little training. So we already saw it in the other slides. There are two ways of how to get from Helicon to the application, and we have the HDevelop, and you can export the code and this goes into the Visual Studio and then the application. And the other version is to save a script, and the script is being interpreted. And we say that we really prefer the the bottom way because we could recommend the HDevEngine and to have an independent development of visions and the rest of the application. So this can be separated very good, and you do not need to compile. So it happens often that people call us and say that they have a problem, and we look at it and we change it and we save the script, and then the application and the image processing is changed without needing to combine newly. So I use the HDevelop as long as possible and use this tool. And I have started a fantasy application, just an example image from the example, have an example script. And for example, if the customer wants to measure the aluminum pads and you want to see how to get this into the application. And many do not know that that there is an hrun, an execute script. You can execute the script using hrun, and you can see that the window opens, and you can click through the images because I programmed the system like this, and you can test this immediately. And this is not the usual way. There's also the HDevEngine API, and you can open the program call. This is the unusual way. You can work with procedure call. This is I'm going to show you as well. So you have your image processing solution that you have developed in Helicon, and the part that you want to have, because you want to have inputs and outputs, you can mark it. Just click on the right side of the mouse, you create the procedure, and then you're asked where you want to have this. You can have this locally in a script, and you can also have this and save this in an external procedure, or you can have several procedures and combine this in the library. So I put everything in the same script, the same content. There could be the same name. You can see the colors. This is purple, for example. The internal and the external ones are blue. And now we want to see how to get this into the application. We have all the examples here, and it also works with C++. And the upper part is the declaration. You can see if it's a local procedure, you have to say where the script is. And you can use a procedure call. And the runtime, you can see the bottom part, the execution. If all the information is there, then you can execute and you can pick up the outputs. And this looks almost similar in the bottom part, and only the upper part changes a little bit, the declaration. But it's pretty similar. You only have to say where the procedure comes from. And also here, the library procedure, the bottom part is identical, and the upper part changes a little bit. So if you imagine that you have a library with many procedures and many inputs, you can see it below that there is a lot of writing effort. And I, as a Helicon developer, maybe do not care about it, but others do. So you have the library export. I also saw it last year in the Innovation Day. It looks like this. It is a very small declaration, and the execution is also very small. And why is that easy? MVTec does the work. You can take the library, you can export it, and a window opens, and you can decide whether this is C++ or something else, and you can export this, and then you get a source code that you can include in the project, and all this writing effort can be avoided. And how do we work regarding development processes? We are a small team. We work with different customers. We work with big projects. And we recommend that if you sit down and that you define some general easy rules like a simple code style guide, what names you want to have, the common in and outputs, how is there a color code, who is responsible for what, can use the machine. We are a service provider, so how are tasks assigned and tracked, is there a collaboration tool, and if this is made clear, then we define the tasks for the process, and we define the necessary outputs, we make some we have some discussions, and then we do a first definition, and we can document this. We did this here in PowerPoint, for example, because you can paint here also. And then you think about the inputs that are needed to make this process. And this sounds not very spectacular, but it's very important for us. In a bigger project a few years ago, we used version control for the first time, and since then we're using it always. Here was with Muckenhörn, it was automation, and each developer can push and pull, and also team members without developer skills may pull the code here or there, for example, can be told to them. And all the modifications are documented, and changes may be merged, and conflicts can be resolved if something goes wrong, revisions can be reverted. And what has also established for us is that we have branches. So we have a development part, we have for example, if we can make a release candidate, and there is a procedure that says if the RC candidate passes the exam, so to speak, then it's released. And this is really very helpful. And it helps us a lot. And this is the visualization. There are two sides. We create a result image using an invisible Helkin window, and with the operator dump window image, we dump what we have put into this, and we have you can transform this into every format that you want. And the second alternative, it looks a bit better and has more functionalities, is we have a window handle as input to display directly in a Helkin window in HDevelop. This is our window here in HDevelop. And you can also work with Smart Window Control, WPF, you can zoom, you can pin, so it looks very good, and the customer really liked it. And then the next question is how to debug and to see what went wrong. The first thing, it sounds not really spectacular, but it's helpful, is to have a meaningful visualization. Then you can have error handling, error codes, error messages that are helpful. And what we also do is a debug level. Debug level 0 is mostly for the operator, for example. So we visualize only what is important in the step, and debug level 1 is for the engineer. So I visualize where the measuring regions are, and where are they, and are they on the correct side or position. And the debug level 2 is for the developer, and this is something that only the developer understands most of the time, and the others do not know what it is about. So this is what we do. And if I want to go into detail, there's only the remote. There's also the remote debugger, and this is the feature that the customer really was really impressed by. So with the remote debugger, I can look at the process, I can see which codes are used and which variables. This is really great. And what we say is that we have to make sure that we can debug offline, and that all the procedures can be separated, the hardware and the image processing sides. So separate the image processing part from hardware-dependent parts. So we have the MYP procedures, and that we see that this is also works with Halcon. And how can we do this? You have the procedure, the control ins, control outs, and you need the inputs, and you can save the inputs and outputs in a structured way. You give a ID, you can save all the objects in a structured way, and you can have a CSV, for example, where all the data is, and then the client can send us the images, and we can have this also the vector, and we can go through this and we can process the data. And the second thing, this was also very interesting. We did this together with Ecklemann. It was a test. We called this test set call, and you zip all the inputs that you need as a data. You put it into a zip data. And this was really interesting because in the zip data, you also have a HDev data, and this creates a Halcon script in a dynamical way. And if you click on it, there are predefined processes and procedures, and the procedure that is being executed is the one that I have in my procedure agenda. I will talk about this later. And the last possibility is dicts, the dictionaries. So all data types available except of vectors and can be stored in a dictionary. And if you have a shape-based matching, etc., if you have a dictionary, all the information that is behind that handling can be saved. And so you can write a procedure with a generic interface, with input, output. This is very helpful, and these three methods can also be combined. And now we're going to have a practical example. So Dietrich Treves is the responsible at Sune, and he calls me and says, we have a slightly changed product design, creating a potential issue in process step 11. I took some images and uploaded them to the image server. Can you have a look into the procedure, FTP position left? And he also tells me we are using a release candidate branch revision 18.4.7, but we have still not updated Halcon, so we use steady 18.11. So this is a support call. So I go on the server, I have access from the client, and I get the images from Huber and Sune, and I have different data that contains the information of each individual part, and also parameters like pixel dimensions, for example, that are being calibrated globally. And I also need the scripts, of course. So I have many different customers, and we have often several projects going on at the same time. So I look at the different clients and make an update with the release candidate. And now in this file, the scripts are available, and I open with the new software manager, the Halcon version 18.11.3, and I can use the managed procedure to see that this works with the information from the repository. Now I use the data from Huber and Sune, and my HDevelop reacts the way it would do with the machine. The same scripts are used, the same Halcon version is used, and I have the pictures and the input that the procedure saw, and now I have to feed in the procedure. I have a loop here of all the images. I use the txt files and others. I have the inputs, and I send the inputs with the procedure. I can debug this, and I can see, oh, okay, with this design, I have to change something so that there is no exception, and I do the change. I push the code to the repository, and the responsible person can go into their application, updates up to the newer version 1848, for example, and the problem is solved. This is a really easy process. And if I want to fix and I forgot to about what I thought back then, you can document a procedure, and you have this procedure on your computer, and you can step on F1 and you can see what the developer has thought while developing, if he documented or she documented it. So this was everything about the development process and how we see it. And now let's get to the last slide, the summary. So we are fans of HDevelop in combination with the HDevEngine. It is highly flexible and provides an efficient and fast development process. We always think that we're fans of separating the image processing development and application development, tool and team members. We stay as long as possible in H development, and as I mentioned, we are service providers, and we offer HDevEngine from the small vision sensors up to high performance PCs. And I showed you the different ways of how to integrate this. And I recommend to control the versions and think about the use version control, and don't neglect debugging, data logging. And this was my presentation. I hope you liked it, and I'm looking forward to your questions.